Alright, y'all, in these examples we'll be adding and multiplying radical expressions. Now when you add radicals, the insides must match, and what we do is we add the numbers on the outside, like the a plus c here, and then the radical part stays the same. You do not change your radicand when adding. Now when multiplying, inside a radical can multiply by inside a radical to get me a square root of a times b inside that radical. Now if you got numbers on the outside, outside numbers can only multiply by other outside numbers. Outside numbers cannot multiply by what's inside the radicals. Okay? So watch these examples and see what I'm talking about. So the first one, I'm going to do 5 square root of 10 plus 2 square root of 10. Now, these radicals match up, and notice, first thing I want to do is simplify. Well, square root of 10 will not simplify because there's no factors that are perfect squares. So what I would do, since the radicals match up, the answer is going to have to be square root of 10 under the radical. But what I do now is add 5 plus 2 to get 7. So altogether I got 7 square root of 10s. Alright, y'all, number 2 is 5 square root of 2 plus 2 square root of 2. So notice, once again, the radicals match, and they cannot be simplified, because 2 is pretty much a prime number and it won't break down. So then the answer is going to be square root of 2's for the radical part. Now we need to see how many we got. So I got 5 here and 2 here. 5 plus 2 gives me 7 square root of 2's. And let's try one with a little subtraction. How about 6 square root of 8 minus 5 square root of 2's. So notice, as they stand, we can't add these because the 8 and the 2 don't match. So what we need to do is see if we can simplify one of these radicals. So I'm looking at the 8 here. 8 will break into a 4 and a 2, and then that gives me a 2 and a 2 for the 4. So notice, what you want to do is bring down that 6, and since I know the 8's going to simplify because I got a pair of 2's here, remember these two 2's make a pair, and 2 times 2 gives me 4, so under the first radical I'm going to put a 4. Now I got another 2 left, and I'm going to put that in my second radical. Remember, when we simplify radicals, we break them apart into the perfect squares and in the numbers that don't have perfect squares. Now we couldn't do nothing with that square root of 2, so we're going to bring that term down. Alright, so now what we want to do, we can simplify the square root of 4. So bring down that 6. That's going to multiply by what we get out of that square root of 4. Well, the square root of 4 is 2, so that's going to give me a 6 times 2. Bring down that square root of 2 minus the 5 square root of 2 from earlier. Now remember, before I can subtract or add, I got to do my multiplying. And here's a 6 times 2. So that's going to give me 12 square root of 2's minus my 5 square root of 2's. So any numbers we bring out get multiplied by numbers that are already out there. Now notice the radicals match. So the answer is going to be square root of 2's. We just got to figure out how many. Well, I got 12 minus 5. 12 minus 5 is 7. Alright, then I can't simplify that no further, so that's my final answer. Alright, let's do another one like that, but it's going to be adding. 3 square root of 80 plus 9 square root of 45. Alright, so it looks like I'm going to try to break down both of these numbers, because they both look like they might break down a little bit. So let me start with my 80. I can make that an 8 and a 10. The 8 can be a 4 and a 2. That 4 will break into a 2 and a 2. That 10 will give me a 2 and a 5. So let's see what I got. I'm going to bring down the 3 and make my 2 radicals, and then we'll do that with the second one. So let's see. Here's a pair of 2's. That's going to give me a 2. Here's a pair of 2's. I'm going to multiply that 2 that I got from them by the 2 I got from those 2. And then the 5 don't have a pair, so it's going to stay here. So altogether we got 1, 2, 3, 4 2's. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we're going to break a 16 out of that. And then 80 divided by 16 will give me that other 5. So remember, since the 5 don't have a pair, it stays in its own radical. Now let's bring down to 9 and make 2 radicals for the 45. So let's break down to 45. 45 will be 9 and 5, and the 9 can be a 3 and a 3. So notice I got a pair of 3's here, so that's going to come out as 1, 3 eventually. Now let's put them under a radical. 3 times 3 is 9, and then I got that 1, 5 left by itself. So remember, before we want to add, we want to simplify these 2 radicals. So bring down that 3. That's going to multiply by the square root of 16, which is 4. Bring down that radical 5. Plus over here I got my 9. That's going to multiply by the square root of 9 under the radical, which is a 3. And then bring down that square root of 5. Alright, so remember, we're going to multiply before we do any adding and subtracting. So here we got 3 times 4 is 12 square root of 5's, plus 9 times 3 gives me 27 square root of 5's. Notice now they both have square root of 5's, so the final answer will be square root of 5's. Let's see how many we got. We got 12 plus 27 gives me 39 square root of 5's. Alright, let's see number 5. 11 square root of 50 plus 9 square root of 50. Alright, so these radicals match up, but they will simplify. So we want to simplify these first, because remember, before we add, we got to work parentheses, and we treat radicals like they're parentheses, really. So let me bring down that 11 and make 2 radicals, and then I'll bring down this 9 and make 2 radicals. So we want to break down to 50. So 50 is what? 25 and 2, and then 25 breaks into a 5 and a 5. So I got a pair of 5's, which gives me 25 under that radical, and that means that the 2 that's left over goes in the second radical. And that's going to be the same thing for the second part. You're going to get me a 25 here and a 2 there. Alright, just like earlier, we're going to bring down that 11. It's going to multiply by the square root of 25, which is 5, and then bring down that radical 2. Plus this 9 is going to multiply by the square root of 25, which is 5, and then bring down that radical 2. Alright, so since we got multiplication shown, we got to multiply first. So 11 times 5 is 55 square root of 2's. Plus over here I got 9 times 5 is 45 square root of 2's. And then finally, the answer will be square root of 2's. And let's see how many we got. We got 55 plus 45, which gives me 100 square root of 2's. Alright, so that was 5. Here goes 6. Alright, 6 has 3 terms. I got a 4 square root of 12 minus a square root of 192 plus 5 square root of 108. Alright, so we're going to try to simplify all these radicals. So let me bring down the 4, and then this one will make 2 radicals, and then the 5, and then that one will make 2 radicals. So 12 can be 4 and 3, which gives me what, a 2 and a 2. I got a pair of 2's here, so 2 times 2 gives me 4, and then 3 goes in the second radical. 192, let's see, 192 will divide by 2 and give me 96 and 2. So you can keep doing these by 2. 96 will be 48 and 2. Then I know 48 could be like 12 times 4. 12 can be 4 and 3. 4 will be 2 and 2, and then that 4 will be a 2 and a 2. Ooh, so let's see what we got. We got a pair of 2's, another pair of 2's, another pair of 2's. So I got 3 pair of 2's and then a 3. So let's put the 3 here, and then 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Now see how 64 will be a perfect square root, that 4 will be a perfect square root. So we know we're going to see what happens if we put a 3 under here, because all these got a 3 under there. So let's see what 108 divided by 3 will give us. That'll give me 36, and guess what? 36 is another perfect square. But remember, you could go over here and break down that 108 into a 36 and 3. That would have gave you 6 and 6, which would have gave me 3 and 2. And a 3 and 2. So notice I had a pair of 3's, and then I had that pair of 2's. 3 times 2 is 6, times 3 is 18, times 2 is 36, and then the 3 was left over. Alright, before we add, we got to do all these radicals. So that 4 comes down, times the square root of 4, which is 2, and then bring down that radical 3. Minus square root of 64 is 8, bring down that radical 3. Plus this one has 5 times square root of 36 is 6, and then bring down that radical 3. Alright, so these got to be multiplied and these got to be multiplied before we can add and subtract. So 4 times 2 is 8 square root of 3 minus 8 square root of 3 in the middle, plus here 5 times 6 is 30 square root of 3's. So y'all, let's see what's happening on that. And when we add like terms, here you got a positive 8 square root of 3 minus 8 square root of 3, so those cancel, and all that's left is 30 square root of 3. Alright, let's see. 7 wants me to start multiplying. So square root of 3 times the 7 minus 3 square root of 3. So I'm going to multiply first and then try to simplify. Now, there's not a number in front of this square root of 3, so treat it like a 1. Because this 7 don't have a radical, that means that 7 cannot multiply by that 3. Outside numbers cannot multiply by inside numbers. So 1 square root of 3 times 7 is 7 square root of 3's. And then it's going to be minus square root of 3 times a negative square root of 3. Well, the square root of this negative 3 here can only multiply by the 1, so that's going to make that a negative 3. And then now the radical has, underneath is a 3 times a 3, which will give me 9. So insides can only multiply by insides and change those. Now, I can go further because I can simplify that square root of 9. So that's going to be 3 times, what is the square root of 9? 3. So remember, we got to multiply before we subtract. So I got 7 square root of 3 minus 3 times 3 is 9. Now, since that has a radical and this number don't, they're not like terms, and I'll stop there. Alright, number 8, similar to that, a square root of 5 times square root of 11 minus square root of 7. Now notice, everything on this is under radicals, so when I multiply, everything's going to be under that radical until I simplify. So a square root of 5 times square root of 11 is a square root of 5 times 11 is 55. And then it's minus square root of 5 times square root of 7 is the square root of 5 times 7 is 35. Now, let's see, 55. I'm going to try to see if they simplify. That'd be what, 5 times 11. That's as far as I go, and I got no pairs, so the 55 won't simplify. Let's try 35. That could be what, 7 times 5. It has no pairs, so that means that 35 won't simplify, and that's my final answer. Alright, 9 looks like a little foiling. Square root of 7 minus square root of 3 times square root of 7 plus square root of 3. So these are conjugate pairs. They're the same except one's being minus, one's being added. So watch what happens. Everything's under the radicals, so when I FOIL, I'm going to keep everything under the radicals. 7 times 7 is 49 under that one. Then a positive times a positive is the positive square root of 7 times 3 is 21. Now I got a negative times a positive is going to be a negative square root of 3 times 7 is 21. And then I got a negative times a positive, which is a negative square root of 3 times 3 is 9. So let's see. We're going to simplify our radicals. Square root of 49 is 7. Now I can't simplify these radicals, but look what I got. I got a plus 1 square root of 21, a minus 1 square root of 21. So those two cancel and they're gone. And then I got what? Minus square root of 9 is 3. And y'all look at that. 7 minus 3 is 4. So anytime you FOIL conjugate pairs, you end up with a single number. Radicals will be gone. Alright, y'all, I'm going to try to squeeze in a few more of these. Here I got square root of 3 plus 3 square root of 2 times square root of 3 minus 3 square root of 2. So notice these are conjugate pairs too. They're the same except one's being added and one's being subtracted. Alright, these both can stay under the radical because they're both under the radical. 3 times 3 gives me square root of 9. Now let's do this one. That's a positive times a negative is a negative. The 3 is outside. And remember, in front of that radical is like a 1. So that's going to give me 3 when I multiply them. And then a square root of 3 times square root of 2 is a square root of 6. Now let's do the inside. This is a positive 3 times a positive 1. And a positive times a positive is a positive 3. Square root of 2 times 3 is 6. And then we got a positive times a negative. That'll be a negative. 3 times 3 on the outside is 9. And then under the square root, you got 2 times 2 is 4. Alright, so look, since they were conjugate pairs, those cancel again. So all I got is a square root of 9, which is 3. Minus here, I got 9 times the square root of 4, which will give me what? 9 times 2. Now, before I can subtract, I got to multiply. So that's going to give me 3 minus 9 times 2 is 18. And then 3 minus 18 is negative 15. Alrighty, let's see. Let me do one of these that's not conjugates like number 12. 9 minus square root of 2 times 2 plus a square root of 2. Alright, so I got to work quick because I only got a minute or two. 9 times 2 is 18. 9 times the square root of 2 is a positive 9 square root of 2. So inside and outside can't multiply. Here I got a negative square root of 2 times 2 is a negative 2 square root of 2. This 2 has to stay on the outside because it's not under a radical. And then a negative times a positive will be a negative. Square root of 2 times square root of 2 is square root of 4. Now, 18 comes down. 9 square root of 2's minus 2 square root of 2's will come down. And then the only thing I'm doing this step is bringing out the square root of 4, which is a 2. Alright, so my like terms will be the 18 and the negative 2, which give me 16. And then let's see what I got here. 9 square root of 2 minus 2 square root of 2 is a positive. 9 minus 2 is 7 square root of 2's. Remember, when I add the radicals, I do not change what these radicals look like. Alright, y'all, good luck, and I'll see y'all later.